What's up, you freaking geniuses? So in this video, I'm going to teach you how to evaluate trig functions of quadrantal angles. All right, so we're going to go over these few examples right here. And there's a couple of things that we need to remember. First of all, we want to remember the trig definitions. So for sine, cosine, tangent, cotangent, secant, and cosecant, they're written right here, right? So the sine of an angle theta is y over r, cosine is x over r, tangent y over x, and then we have those flipped with our other three. All right, so that's one thing. Then the other thing that we want to think about is for specifically quadrantal angles. Let's draw some axes right here. There's four specific angles that we're talking about. That's here, 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 and here. All right, so if we're talking about degrees, this is 0 degrees, right? 90 degrees, 180 degrees, and 270. If we're talking about radians, this is, again, 0. This is pi over 2. This is pi, and this is 3 pi over 2. All right, now the last thing that we have to do is just label these 4 points. And the easiest way to do this, if you have a choice, is to label this xy coordinate as 1, 0, this one as 0, 1, this one, let's see, -1, 0, right? -1, 0, and then this one down here as 0, -1. So as you can see, all these 4 points are 1 unit away from the origin, all right? So that means that this distance right here, this is our r distance. So we're saying that r, the distance from the origin to any of these points, is equal to 1. Okay, so let's undo that. So now let's go to this first example. We want to find the sine of 0 radians, or 0 degrees. Would be the exact same thing in this case. How do we do that? Well, the sine of 0, first, let's figure out what sine is, right? So if we look at the trig definitions, the sine is equal to y over r. All right, so this is the sine is equal to y over r. So we want to figure out what y and r are at 0 degrees, or 0 radians, all right? So let's look at 0 degrees, right? 0 radians is right there. This is our x coordinate, this is our y coordinate, right? So what is y and what is r at 0? Y is given as 0. So we're going to plug in a 0 up here for y. Okay, and then r, we said we're going to assume that r is the exact same number for all 4 of these, right? We said that r was going to be equal to 1. So we're just going to plug in a 1 right there for r. All right, so 0 divided by 1 is simply equal to 0. All right, so that means the sine of 0 is equal to just 0. All right, let's try now the cosine of 0. All right, so first of all, the trig definition for the cosine, let's see, cosine is x over r. Okay, so let's figure out what x and r are equal to at 0 radians, or 0 degrees, all right? So again, that's going to be this spot right here. Again, we can assume that r is going to be equal to 1, and here, this time we're looking for what x is equal to at this spot, and it's equal to 1. All right, so we're going to plug in a 1 for x right here. So this is going to be equal to 1 over 1 this time, which is equal to simply 1. All right, so the cosine of 0 is equal to just 1. All right, now what about the cosecant of 3 pi over 2? All right, this is a little bit harder, but not that much harder really. The cosecant of theta is equal to r over y. All right, so this is going to be equal to r over y. All right, so we want to figure out what r and y are equal to at 3 pi over 2. All right, so let's go down here to 3 pi over 2. This is our x coordinate, this is our y coordinate. We know that r is going to be equal to 1, right? It's going to be the same thing for all of them. And for y, in this case, y is equal to -1, all right? Y is equal to -1. So 1 divided by -1 is equal to simply -1. So the cosecant of 3 pi over 2, again, is equal to -1. Now, what about the tangent of pi over 2? So let's look what tangent is equal to. The tangent is equal to y over x. All right, so this is equal to y over x. So we want to figure out what x and y are equal to at pi over 2. So let's look for pi over 2, which is up here at 90 degrees, right? So this is our x coordinate, this is our y coordinate. So let's plug those two in right here for y and x. Y is on top, so we're going to put a 1 on top. So this is going to be equal to 1 on top, and x is equal to 0 at this spot. And here, we can't divide by 0, right? So this spot, the tangent of pi over 2, there's actually no answer. You would simply write undefined. Boom. Okay, now lastly, the cotangent of negative pi. All right, so the cotangent, first of all, is the reciprocal function of tangent. So that means if tangent is y over x, cotangent is going to be equal to x over y. And we can obviously confirm that by just looking at the table up here, all right? So this time we want to figure out the cotangent of negative pi, all right? Pi is the same thing as 180 degrees, right? So if we rotate positive 180 degrees, we would land right here. But if we rotate negative 180 degrees, well, in this case, we'd still land right here. So in any case, we're looking for the x and y values at this spot right here, right? So this is our x, this is our y. So x looks like it's -1 and y is 0, right? So again, we cannot divide by 0. So in this case, our answer would once again be undefined. Boom. So if you found the video helpful, make sure to leave a thumbs up down below. And if you have any questions, let me know in the comments section below.